The rig uses many pieces of equipment to circulate and treat or condition the mud. Mud circulation begins here, in the mud tanks, sometimes called the pits. Crew members prepare the mud in these tanks and make it ready for circulation. The heart of the circulating system is the mud pump. Often, rigs have two pumps, one primary pump and one for backup. Or, if hole conditions require it, the driller can compound or combine the two pumps to circulate large volumes of mud. In fact, on deep wells, the rig may have 3 or 4 compound pumps. The powerful pump or pumps pick up mud from the mud tanks and send it to the drill string and bit. The pump moves the mud into the discharge line, up the standpipe, and into the rotary hose. The standpipe takes the mud about halfway up the mast. The rotary hose is attached to the standpipe. The rotary hose is strong, flexible hose that moves with a swivel as it goes up and down in the mast. From the rotary hose, the pump moves mud through the swivel and then down the kelly and drill string. On rigs with a top drive, the mud moves through a passage in the top drive and then into the drill string. The pump moves the mud down the drill string to the bit. At the bit, the mud jets out of the openings or nozzles in the bit. The jets of mud move cuttings away from the bit. Mud then continues up the annulus, carrying the cuttings with it. From the annulus, the mud with the cuttings in it goes through the return line, sometimes called the flow line, to the shale shaker. The shale shaker removes the cuttings from the mud. The mud then falls into the mud tanks, where the mud pump can pick it up and continue the circulation process. Mud is made up at the rig location. Most rigs have several steel mud tanks. Mud and additives are mixed and held in the tanks. Some land rigs also have a reserve pit dug out of the ground. Mud tanks are also called mud pits, a carryover from the days of earthen pits. Mud tank is the preferred term. The rig does not necessarily use all the mud tanks at once, although it does use several. The active tanks hold mud the pump actively circulates. Often, mud components come to the rig in sacks. Normally, the crew stores the sacks in a special compartment called the mud house or sack room. The house or room keeps the sacks dry and allows them to be stored with care. These silo-like tanks are bulk tanks, or P-tanks. They hold mud additives like barite and bentonite. Crew members use some additives in such large quantities that suppliers load them into the bulk tanks to save time and money. Bulk tanks usually have their own hopper or pneumatic system for transferring the additives to the mud system. The pump takes the mud out of the active mud tanks and circulates it through the system. Crew members connect the mud tanks with the piping and manifolds. The number of active mud tanks depends on the amount of mud needed to keep the hole full, and the volume required on the surface to keep the mud in good condition for circulating. The sand trap is the tank directly below the shale shaker. The shale shaker removes most of the cuttings from the mud, but some are so small the shaker cannot trap them. These fall into the sand trap. The sand trap is the first settling tank. Crew members have to clean it regularly to remove the built-up solids. Some small or old rigs may have 2 or more settling tanks in the tank system. They allow solids in the mud to settle out, but settling tanks do not do a very good job as compared with newer generation solids removal equipment. So, today, most rigs use a desander and desilter. Reserve tanks are not a part of the active mud tank system. Instead, the crew uses them to hold excess mud. Or they may use them to mix a different type of mud than the pump is currently circulating. They may also store heavy mud for emergency well control operations. A slug tank is a relatively small separate tank, or it may be a small separate part of a larger tank. The crew uses the slug tank to mix a slug. A slug is a small amount of heavy mud that is pumped down the string. Crew members may also use a slug tank to mix a small amount of mud for a special purpose. For example, the driller may need to place or spot a small quantity of high viscosity mud, also called a pill, at some point downhole. The suction tank is where the mud pump picks up mud ready to circulate downhole. Mud in the suction tank should be clean, free of solids and gas, and be properly formulated or conditioned. Crew members use the chemical tank to mix special chemicals, such as caustic, that they will put into the active mud tanks. On some land rigs, the rig owner digs a large pit next to the rig. This pit is called the reserve pit. The crew puts waste mud and runoff from the rig site in the reserve pit. In an emergency, they can also use it as a place to put more mud than the tanks can hold. Often, the rig operator lines the reserve pit with a thick plastic sheet to prevent liquids from leaching into the soil. And, if the rig is on a migratory bird flyway, the operator covers it with netting to keep the waterfowl from landing in it. Land rigs drilling in environmentally sensitive areas will not have a reserve pit. Instead, wastes and runoff are hauled to an approved waste disposal area. Powerful mud pumps pick up mud from the suction tank and circulate the mud downhole, out the bit, and back to the surface. Although rigs usually have 2 mud pumps, and sometimes 3 or 4, normally they use only one at a time. The others are mainly used as backup in case one fails. Sometimes, however, the rig crew may compound the pumps. That is, they may use 2, 3, or 4 pumps at the same time to move large volumes of mud when required. Rigs use one of 2 types of mud pumps: triplex pumps or duplex pumps. Triplex pumps have 3 pistons that move back and forth in liners. Duplex pumps have 2 pistons that move back and forth in liners. Triplexes have many advantages. They weigh 30% less than a duplex of equal horsepower, or kilowatts. The lighter weight parts are easier to handle and therefore easier to maintain. The other advantages include: they cost less to operate. Their fluid end is more accessible. And they discharge mud more smoothly. That is, a triplex's output doesn't surge as much as a duplex. One of the most important advantages of triplex over duplex pumps is that they can move large volumes of mud at the higher pressures required for modern deep hole drilling. Triplex pumps are gradually phasing out duplex units. In a triplex pump, the pistons discharge mud only when they move forward in the liner. Then, when they move back, they draw in mud on the same side of the piston. Because of this, they are also called single-acting. Single-acting triplex pumps pump mud at relatively high speeds. Input horsepower ranges from 220 to 2200, from 164 to 1641 kilowatts. Large pumps can pump over 1100 gallons per minute, over 4,000 liters per minute. Some big pumps have a maximum rated working pressure of over 7,000 psi, over 50,000 kilopascals, with 5-inch 127mm liners. Here's a schematic of a triplex pump. It has 3 pistons, each moving in its own liner. It also has 3 intake valves and 3 discharge valves. It also has a pulsation dampener in the discharge line. Look at the piston at left. It has just completed pushing mud out of the liner and through the open discharge valve. The piston is at its maximum point of forward travel. The other 2 pistons are at other positions in their travel, also pumping mud. But right now, concentrate on the left one to understand how the pump works. The left piston has completed its backstroke, drawing in mud through the open intake valve. As the piston moved back, it lifted the intake valve off its seat and drew mud in. A strong spring holds the discharge valve closed. The left piston has moved forward, pushing mud out through the now open discharge valve. A strong spring holds the intake valve closed. The left piston has completed its forward stroke, the full length of the liner, completely discharging the mud from it. All three pistons work together to keep a continuous flow of mud coming into and out of the pump. Crew members can change the liners and pistons. Not only can they replace worn-out ones, but they can also install different sizes. Generally, they use large liners and pistons when the pump needs to move large volumes of mud at relatively low pressure. They use small liners and pistons when the pump needs to move smaller volumes of mud at relatively high pressure. In a duplex pump, the pistons discharge mud on one side of the piston and, at the same time, take in mud on the other side. Notice the top piston and liner. As the piston moves forward, it discharges mud on one side as it draws in mud on the other. Then, as it moves back, it discharges mud on the opposite side and draws in mud on the side where it had earlier discharged it. Duplex pumps are therefore double-acting. Double-acting pumps move more mud on a single stroke than a triplex. However, because they are double-acting, they have a seal around the piston rod. The seal keeps them from moving as fast as a triplex. Input horsepower ranges from 190 to 1,790, or from 142 to 1,335 kilowatts. The largest pump's maximum rated working pressure is about 5,000 psi, almost 35,000 kilopascals, with 6-inch 152 millimeter liners. A mud pump has a fluid end, power end, and intake and discharge valves. The fluid end of the pump contains the pistons with liners, which take in and discharge the fluid, or mud. The pump pistons draw in mud through the intake valves and push mud out through the discharge valves. The power end houses the large crankshaft and gear assembly that moves the piston assemblies in the fluid end. Pumps are powered by a pump motor. Large modern diesel-electric rigs use powerful electric motors to drive the pump. Mechanical rigs use chain drives or power bands, belts, from the rig's engines and compound to drive the pump. A pulsation dampener connected to the mud discharge line smooths out surges created by the pistons as they discharge mud. This is a standard bladder-type dampener. The bladder in the dampener body separates pressurized nitrogen gas above from mud below. The bladder is made from synthetic rubber and is flexible. When mud discharge pressure presses against the bottom of the bladder, nitrogen pressure above the bladder resists it. This resistance smooths out the surges of mud leaving the pump. Here is the latest type of pulsation dampener. It does not have a bladder. It is a sphere about 4 feet or 1.2 meters in diameter. It is built into the mud pump's discharge line. The large chamber is full of mud. It has no moving parts, so it does not need maintenance. The mud in the large volume sphere absorbs the surges of mud leaving the pump. A suction dampener smooths out the flow of mud coming into the pump. crew members mounted on the triplex mud pump suction line. Inside the steel chamber is an air-charged rubber bladder, or diaphragm. The crew charges the bladder about 10 to 15 psi, 50 to 100 kPa. The suction dampener absorbs surges in the mud pump suction line caused by the fast-moving pump pistons. The pistons constantly start and stop the mud's flow through the pump. At the other end of the suction line, a charging pump sends a smooth flow of mud to the pump's intake. When the smooth flow meets the surging flow, the impact is absorbed by the dampener. Workers always install a discharge pressure relief valve. They install it on the pump's discharge side, in or near the discharge line. If for some reason too much pressure builds up in the discharge line, perhaps the drill bit or annulus gets plugged, the relief valve opens. The open valve protects the mud pump and system against damage from overpressure. Some rig owners install a suction line relief valve. They install it on top of the suction line, near the suction dampener. They mount it on top so that it won't clog up with mud when the system is shut down. A suction relief valve protects the charging pump and the suction line dampener. A suction relief valve usually has a 2-inch or 50 mm seat opening. The installer normally adjusts it to a 70 psi or 500 kPa relieving pressure. If both the suction and discharge valves failed on the same side of the pump, a high backflow or a pressure surge would occur. The high backflow could damage the charging pump or the suction line dampener. The discharge line is a high-pressure line through which the pump moves mud. From the discharge line, the mud goes through the standpipe and rotary hose to the drill string equipment. The shale shaker mechanically takes out the large cuttings from the mud. It does not, however, remove very fine cuttings and other small solid particles. These solids can be fine sand particles and other very fine materials, often called silt. Good drilling practice requires removing these undesirable solids. If not removed, the solids can increase the weight of the mud more than required, reduce the bit's penetration rate, and significantly increase the rate of wear on circulating equipment. The rig uses mechanical solids removing equipment, such as hydrocyclones and centrifuges, to remove the fine solids. Sometimes, the hole penetrates a formation that has small amounts of gas. This gas gets into the mud, becomes entrained in it, and must be removed before the pump recirculates the mud back down hole. A degasser removes entrained gas from the mud. The shale shaker has rapidly vibrating screens. The mud and cuttings from the return line fall onto it. The vibrating screens catch the larger cuttings. These cuttings fall into the reserve pit, the sea, or other container for disposal. The liquid mud goes into the sand trap, which is a special mud tank. Shale shakers look simple. In fact, though, manufacturers carefully design them to make the screens vibrate in a very controlled way. Sometimes, the crew sends mud through a vacuum degasser. The degasser removes gas from the mud. If the gas were not removed, it could make the mud too light, not dense enough. As a result, the well could kick. Formation fluids can enter the wellbore and have to be controlled to prevent a blowout. Another problem: if the driller recirculates gas-cut mud, the gas could cause the mud pumps to gas lock. Gas-locked pumps pump gas and mud instead of just mud, which is highly inefficient. So, to remove gas, crew members use a degasser. In a vacuum degasser, mud with gas in it enters at the top and spills out over several baffle plates, a spreader. Spreading out the mud presents a large surface area for the gas to break out. Also, the vacuum pump creates a vacuum, pressure lower than the surrounding atmosphere, inside the degasser. This vacuum makes it very easy for the gas to escape from the spread-out mud. The removed gas leaves through a vent, which sends the gas a safe distance away from the rig. The gas-free mud falls to the bottom and goes back into the mud tanks downstream from the degasser. A hydrocyclone system consists of several cones. Mud enters through a side opening at the large end of each cone. It swirls around inside the cone. This centrifugal force, or cyclone motion, throws the larger particles to the side of the cone. There, the particles move to the bottom of the cone and drop out. Clean mud goes out the outlet at the top. A desander has large cones. It removes particles as small as about 40 microns. A micron is 1/1,000,000th of a meter, which is very small. A desilter has smaller cones than a desander. Desilters remove particles down to about 20 microns. A mud cleaner has still smaller cones. It removes particles down to about 7 microns. Since barite, that desirable solid which gives weight to the mud, is also about 7 microns, screens are included on mud cleaners to retrieve the barite so it can be returned to the system. Inside the cone, mud enters from the side and spirals down. This movement flings the solids to the side. The spiraling action creates a vortex in the center, somewhat like a tornado. It is an area of lower pressure, so the vortex sucks the liquid mud up through the center and out through the top of the cone. Meanwhile, the solids slide down the side and out the bottom of the cone. The smaller the cone, the smaller is the particle it can remove, but more cones are needed to handle a given volume of mud. A centrifuge spins mud at high speed. This creates centrifugal force. Centrifugal force throws the particles to the side of the centrifuge, where they are removed. A centrifuge removes particles as small as 2 to 5 microns, which includes barite. Sometimes, crew members run a centrifuge at a specific speed to remove barite, so the rig can use it again on the next hole. Occasionally, the rig owner runs 2 centrifuges. The first removes the barite, and the second the finer particles. Crew members then re-add the barite to the mud system. Crew members mount agitators on one or more of the tanks. Agitators stir the mud in the tanks to keep solids from settling and to maintain uniform mud properties. One popular agitator is the paddle type. An electric motor rotates paddles to stir the mud. A pit volume totalizer, or PVT, alerts the driller to changes in the level of mud in the tanks. A float in each tank rises or falls if the mud level rises or falls. For example, if the level rises, the rising floats send a signal to a recorder and to a digital panel on the rig floor. The panel alerts the driller of the rise. This device is called a pit volume totalizer, or PVT, because it measures the gain, or fall, in each of the tanks or pits, totals the gain or fall, and sends this information to the driller on the rig floor. If the mud level in the tanks fall, the PVT also alerts the driller. This float in a mud tank is part of a pit volume totalizer. Usually, crew members install a float in each active tank. The floats rise or fall with the mud level in the active tanks. Mud level in the tanks is vital information. If the mud level rises, it often means that the well has kicked. Formation fluids have entered the hole and forced mud out. The kick fluids replace mud in the hole and cause the mud level in the tanks to rise. On the other hand, if mud begins going into a formation, if mud is lost to the formation, the mud tank level drops. Lost circulation can also be a serious problem. The decrease in height of mud in the hole could lead to a kick because hydrostatic pressure is reduced. Also, drilling without mud returning to the surface is like drilling blind. No communication between the bottom of the hole and the surface exists. The mud system normally has several centrifugal pumps. A centrifugal pump puts out relatively low pressure, but it can move a large volume of mud. Crew members, therefore, use them in several ways. One job a centrifugal pump often does is supercharge the mud intake of the main mud pump. The small pump takes the mud from a suction tank, moves it through a line connected to the main pump's suction line, and keeps the suction line full of mud at all times. If the system does not use a charging pump, the force of gravity alone feeds the pump's suction line. Sometimes gravity cannot keep the pump's intake completely full of mud. The pump pistons suck in the mud so fast that gravity cannot keep the suction line full of mud. The crew also uses a centrifugal pump to mix some mud components. A hopper is like a big funnel. Crew members put sacks of mud material into it. They do not, however, use the hopper to mix caustic soda. The hopper can blow dry caustic back into the face of the worker mixing it. In addition to being dangerous, adding caustic through the hopper can flocculate the mud, cause it to clump up. A crew member opens the sack of material at the top of the hopper and feeds the material into the funnel. At the same time, a jet of mud from a centrifugal pump goes through a nozzle at the bottom of the funnel. This jet creates suction. The suction pulls the material into the mud stream. Or, if hole conditions require it, the driller can compound or combine the two pumps to circulate large volumes of mud. In fact, on deep wells, the rig may have 3 or 4 compound pumps. The powerful pump or pumps pick up mud from the mud tanks and send it to the drill string and bit. The pump moves the mud into the discharge line, up the standpipe, and into the rotary hose. The standpipe takes the mud about halfway up the mast.